Hi, my name is Hannah White, and this is my video for Microbiology Unit 3 homework describing antibiotic resistance. First, I'm going to explain and define antibiotic resistance. Now, the World Health Organization defines antibiotic resistance as a phenomenon that occurs when bacteria no longer respond to medications. Now, because of this resistance, antibiotics become more ineffective against bacteria, which then makes infections much more difficult or even impossible to treat. Now, this is a major medical problem. The CDC estimates that in the US, more than 2.8 million antimicrobial resistant infections occur every year, and worldwide 1.27 billion people die from them every single year. But to understand why this is so important and how we treat it, first we have to know how bacteria actually become resistant. Well, it all starts with a misuse of antibiotics that fails to kill the bacteria during the first course of antibiotics. This is not an allergy. It has to do with something going wrong in the way antibiotics are used. So drugs that previously worked to kill the bacteria can no longer complete the job. Now, scientifically, drug resistance develops because positive mutations within bacteria allow them to resist the effects of antibiotics that previously had killed them. This drug-resistant mutation allows resistant bacteria to survive and continue to reproduce, which passes on that drug-resistant gene to their offspring. So the worst bacteria are the ones that are surviving and creating more bacteria and continuing to make you sick. Now, the drug-resistant gene can also be passed along to other bacteria through the conjugation of plasmid, which is a way that two bacteria can share genetic material with each other. Now, doctors contribute to the antibiotic resistance through overprescription of antibiotics. When antibiotics are prescribed in instances where they're not really needed, it may make future infections harder to treat. Although public health initiatives in healthcare have decreased the number of unnecessary prescriptions in recent years, it is still a phenomenon that occurs. Doctors may prescribe antibiotics for an infection that turns out to be viral in nature, which obviously would not work. Antibiotics only work with bacteria. So in this instance, antibiotics aren't going to help fight this virus. Now, an example of this is sinus infections, which have long been the target of long antibiotic courses. But recent studies have shown that only 0.5 to 2% of these infections are even bacterial in nature. Statistics like these can help practitioners influence how they prescribe antibiotics to their patients. Understanding the length of a viral illness versus a bacterial illness can also help decrease overprescription or unnecessary prescription, which then decreases antibiotic resistance. For example, lots of doctors now will kind of let patients be sick for longer. So if a patient comes in with a sinus infection, they're not just going to immediately treat it with an antibiotic because chances are it's viral in nature. It doesn't need an antibiotic. So if the patient lets the illness run their course and their body naturally fights off that virus, then they shouldn't need antibiotics. But then if the sickness persists, or even if testing comes back, then they know that it's time to prescribe antibiotics. Now, another reason that doctors can contribute to antibiotic resistance is subtherapeutic doses. Because these low doses don't kill all of bacteria, which allows those with the slight resistance to survive. These bacteria then multiply, reproduce, gradually leading to a more resistant population. If an infection isn't fully eradicated due to insufficient antibiotic levels, the remaining bacteria may develop mutations or acquire resistance genes that make them more difficult to treat. This may increase the likelihood that resistant and non-resistant bacteria coexist, which facilitates that gene transfer we talked about earlier. Now, patients contribute to antibiotic resistance as well. Poor patient compliance is one of the major factors that has led to antibiotic resistance. Not taking the correct dosage or not taking the antibiotic throughout the correct time frame, and especially discontinuing antibiotics too early can all lead to antibiotic resistance in the same way subtherapeutic doses do. Misuse of antibiotics allows the more resistant bacteria to survive and adapt to have stronger resistance over time that will, in the future, be harder to treat due to those mutations.